Ladies and gentlemen, allow me to introduce Tenco Hydro's #1 best-selling product historically, the DAF, Dissolved Air Flotation. Dissolved air flotation is best for removing solids, fats, oils, and greases. It can produce a high-quality effluent, and it's great at dealing with things like high solids concentrations, variable influent quality, or ranges of GPMs on the influent, and it typically can do the same thing that other systems can do, but in a smaller footprint. These are the big four in terms of DAF design criteria. There is a lot of information that we look at when it comes to providing a full custom solution for your application, but here's a general overview of some of the things we look for to give you some idea of how we size a DAF. You have the HLR, hydraulic loading rate. You have the SLR, the solids loading rate. You have an air to solids ratio, and then you have a coagulant and flocculant, and you have choices within each of these categories. So let's go through a bit of an example criteria, if you will. In terms of HLR, you're looking at between 1 to 5 GPM per square foot of surface area. So what this means is, in an example application, if you had 500 gallons per minute coming on the inlet, then you would want to have, if you wanted to do 1 GPM per square foot of surface area, you would have 500 gallons per minute, and you would want to have 500 square feet of surface area, and that would give you the value of 1. If you wanted to size it a little bit differently, and there are cases where you would do so, with 500 gallons per minute coming in, you could have as small as 100 square feet of surface area, which would give you an HLR value of 5. Now, those are two very different sizes. Usually, we like to end up between 2 and 3 GPM per square foot of surface area, but one of the factors that we consider when sizing for the HLR is the SLR, the solids loading rate. And this is, basically speaking, how much solids, what percent solids are coming in with that water that's coming in as well. And so, typically, we like to see between 2 and 20 pounds of solid per square foot of surface area per hour. So if we have, for example, a high solids loading rate, somewhere in the range of 15 to 20, then we would want to have an HLR slightly smaller. We would want to have more surface area. And so the more surface area you have, when you divide the GPM over the surface area, you end up with a smaller HLR. So for example, if your SLR is between 15 and 20, you're probably going to want your HLR to be somewhere between 1 and 3, just as a general example. Of course, every application is different, but that's how these two work together. If your SLR is very low, like in the 2 to 5 range, then your HLR can be higher. You can have more gallons per minute coming into a smaller surface area because there isn't a lot of solids that need to be processed through that. So I hope that makes sense with those two. We're just going to keep moving on here because this is just meant to be more of a general overview. Air to solids ratio, we just want a certain amount of pounds of air, when ratioed with pounds of solids. You have the value there is typically 0.005 to 0.050. And then for flash and floc, this is the coagulant and flocculant. And typically this occurs either in a tube or in separate mixing tanks. Now this is the first step of what happens, where the particles are brought in, they're broken apart, and then they're reformed in such a way that they can be cleared out of the system. That chemistry and how whether or not you use a tube or mixing tanks there, it really depends on what your goals are and then what the chemistry is with what waste you have coming in. So it's goal dependent. Mixing tanks can allow for a longer process. They can be a more thorough flash and floc step, but sometimes that isn't needed. Sometimes you don't have enough space for separate mixing tanks, so they have to be loaded on the side of the tank, in which case maybe we would consider something like a tube, as long as we were able to achieve your effluent goals. So here is one example of a DAF system that we created, and I'm just going to try and break it down into the different components again briefly, because this is an overview. If you want to ask additional questions, of course you can reach out to us, but we're going to go through just an overview right now. So you've got coagulant and flocculant tanks, that's that flash and floc that we were speaking about. and then you've got the float tank, and that's where the magic happens. That's where the waste is removed. And then you have the pressurization tank, which is the recirculation into the float tank. So the way the pressurization tank works is it takes water out of the middle of the float tank, and it pressurizes, the way that we do it at least, it pressurizes the water and adds air to the water and then brings that air back into the float tank. And that's where you have that air dissolved in water, dissolved air flotation. So that's where the name comes from. We're going to start with step 1 here. This is the flash and flock, and flash is the first step that typically happens. This occurs with an agitator, and it's a rapid mix. So you have a coagulant in there as well. So the coagulant with a positive charge and the rapid mixing breaks the emulsion of the particles. It's essentially, particulate should be dropped out in this part of the system. After this particulate is dropped out of the water, i.e. at the bottom, floating separately from the water, if you will, the next step is the flocculant, or the slow mixing. This is where you have a flocculant with a negative charge gently mixing these particles together, and you're trying to get bigger particles with entrapped air in them, and they float to the top. You typically are going to have, since this is a slower process, you're going to have a longer retention time. So if it's going to be 2 minutes in the flash tank, it's going to be 5 minutes in the flock tank, or whatever the system requires. But the result here is that we have larger particles that should be floating to the top of the water. Once these particles are ready to be floated to the top of the water and scraped off, they enter into the float tank. This is where waste particles are scraped off. There are some particles that couldn't be flocculated up to the top of the tank, so they end up floating down to the bottom. And there are things that are drained out the bottom as well. So waste particles are scraped off the top and drained out of the bottom. This is where the magic happens. This is the longest detention time of the entire process. And something that is very common is a 50% water recirculation. So half the water that's coming in here is going to be recirculated through that pressurization tank. We're going to talk briefly about the main mechanism of scraping in the float tank. Here in that little blue rectangle that just appeared, that is the skimmer and screw. That is the scraping mechanism that comes off of the top. We're going to do a little bit of a deep dive into this. So the skimmer blade drops in front of the baffle. You see here an image of a tail shaft. So this is at the end of the DAF system. In that big picture, it would be on the right-hand side of the float tank. And you see there's an effluent trough and a baffle. That skimmer blade is what's going to scrape those waste particles all the way down the system to the other end. And that's where it exits. And water overflows here in the effluent trough. Now here is the head shaft. So in that rectangular, that picture of the float tank, this is on the left-hand side. So this is the head shaft. This is where the skimmer blades, this is where the waste is scraped off the beach. So skimmer blades are fixed. The weir plate raises and lowers the water level. The skimmer blade rises up the beach and into the float trough. And this is where things are taken away. So now that we've gone through that scraper mechanism of the float tank, we're going to go into the pressurization tank. This is the recirculation that's happening. Water is aerated and pressurized before returning to the float tank. The key component here that we're looking for is saturation efficiency. How much air can be dissolved into that water? This plays a big role in floating particles to the top in the float tank. The better your saturation efficiency, the more air that you can dissolve into that water, the better off you're going to be in the float tank in terms of removing waste. And I am proud to say that from a third-party analysis of many DAF systems, we came out as #1 in the industry. Our spray nozzle mechanism, and that's what I believe to be the secret sauce of our DAF systems, produced an 87% saturation efficiency in our pressurization tank. So on our recirculation, we achieve an industry-leading 87% saturation efficiency. 87% of the air is dissolved into water. Now we do dissolve under pressure. We need to know the temperature of the process water, as this, since we are dissolving under pressure, it's somewhat temperature dependent. But this is our secret sauce. That spray nozzle right there in the red box, that is how we achieve the saturation efficiency, in my opinion. Of course, the entire system has to be very robust and well engineered in order to achieve that efficiency and to make that happen. But there's a lot of different ways that people will do this. Instead of using a spray nozzle, they'll do things like dump the water over a cone. There's various different ways that you can get saturation of air into water. We have found this to be the number one best way, and via a third-party analysis, it seems to be the number one technology or system in terms of getting air into water. So pretty cool. So here we are back to that same picture as before. This is just a little more detailed now that we've learned all that we've learned. So going from left to right, the flash and flock system gets the influent ready to be treated, and this is where that clear water and the particulate is dropped out, where you've got sort of water and particulate in two separate phases of the system. That goes into the float tank, where waste floats and gets skimmed off. We typically design a 50% recirculation of the water, and again, solids are skimmed off the top, sludge is drained out the bottom. And then lastly, we have our water recirc, where the water is saturated with air. So where do we find these things? There is still DAF systems out there in wastewater treatment plants in the municipal sector. They're great for secondary waste activated sludge, and they have a bigger footprint than their main competitor, but they use quite a lot less polymer. So overall, you have lower operation costs with a DAF system. Now, a belt filter, a press, a screw press, a centrifugal system, these are the large players in the market today. That is what we see, the majority of what we see out there. We do work with these systems. So if you're looking for a belt filter press or a screw press in the municipal market, we can help you with this. I will say that DAF historically is what the company has provided the most of. However, we are changing with the times as well. So we will sell you both systems. We can work with you on both systems. But I will just say that it's not a silver bullet. There are some reasons why there is DAF systems still there, and we are still producing DAF systems for the wastewater treatment plants. And here are some of the reasons why. So, on the industrial side, DAFs can be used in many different places. They're used anywhere oils and greases are emulsified, typically through a cleanup process. If you are having surcharge issues in any way, shape, or form, permit issues, any of that, let's have a conversation, because DAF systems can be great and they can be paired with other things as well. Some of the top customers we have are food processing plants, metal finishing, railroads, can making, refineries. We'll typically do an oil water separator with the DAF system, and then sewer, anything any system that requires or is having issues with sewer or BOD discharges, fats, oils, and greases, or TSS permit limits. There have been a lot of different applications that a DAF has been used for, and we would be happy to find out if ours is the right fit for you. DAFs can't do soluble, like things like sugar, flour, things that are dissolved in water. If it's emulsified, that is doable. But if it's soluble, that's sort of a different story. We would typically look for more of a biological process. Something that we can help with just wouldn't be a DAF system, most likely. So we can do insoluble, or we can coagulate or make insoluble in suspension. We have had hundreds of DAF systems installed since 1977, and we provide turnkey solutions. We can design and build a platform for your DAF. We can install and start up anything that we provide. We can provide expertise on anything water or wastewater. Tenco Hydro is quite the big company when it comes to providing water and wastewater solutions. So whether or not we have the expert or we can point you in the right direction, we'd be happy to do that as well. But we pride ourselves on being a turnkey custom solutions company. We are successful in several different configurations. DAF systems have been provided where we have flash and flock tubes. We have flash and flock mixing tanks are mounted onto the DAF tank. That's where you need a little bit more robust of a flash and flock system, but you have a small footprint. Various different levels of controls integration. We make our own controls panels. We can integrate with the PLC. We have PLC people on staff that we can work with in any way, shape, or form. And we will not shy away from your application. There is no hydraulic loading rate too high. There is no discharge limit too low. We will look at your application and we will do everything we can to give you the best solution that we can. So we're nearing the end here, and here are some questions that you might want to ask yourself or you want to reach out to us and talk to us about. Some things that we would typically look for where a DAF might be the right solution is, number one, are you being surcharged on your waste, on your effluent? Are you exceeding permit limits for your discharge, or are you trying not to exceed permit limits? If you have a grease trap, how's the grease trap working? Sometimes grease trap's all you need. There's a lot of applications where maybe it was put in place originally, but you may need to upgrade your wastewater system, and we'd be happy to take a look at that for you or with you. Do you have an existing wastewater system that needs any help or modifying? Any system that you currently have, let's take a look at it and maybe see how we can optimize the system you already have. If it turns out you need a replacement DAF, or you need other water or wastewater treatment systems that need to be put in place to modify or augment and help what you already are working with, we would be happy to help you with that as well. Thank you very much, and I hope you enjoyed this video.